Hello guys, this is Nikhil Bansal from Illuminate Minds. Today we are going to write the code for the abundant number. So first you need to understand what is an abundant number. An abundant number is one where if I add all the proper divisors of a number and if the sum of the divisors comes out to be more than the number itself, which is 18 in this case, and the sum is equal to 21 as you must have noticed, right, then 18 is an abundant number. Another example is 49. In case of 49, the proper divisors are 1 and 7. So if I add all the proper divisors of number 49, which is less than 49, the number, so sum of the proper divisors is equal to 1 plus 7 is equal to 8. Hence, 8 is less than 49. Hence, 49 is not an abundant number. I hope you have understood the definition of an abundant number. Now, how we are going to do this in code? We need to find out factors for a number. So we will count all the factors for a number, and we have done this in the prime factors program also. And we will set a counter which will add all the proper divisors of a number. Right now, to which extent should I run the iteration for finding out whether this is a factor of it, and then add the number to a summation to a counter? Right, you will say that I should do it for till half n by 2, but that's wrong. We will still go with under root of 18, greatest integer, and in one iteration we'll find out the two ones. So supposedly if 2 comes out to be a factor of 18, a divisor of 18, proper divisor, then 18 by 2 I will also fetch 9 in it. Similarly, once I get 3, I will also get 6 in it. Similarly, 1 I will get 18, and once I've added all the factors, prime factors of the number of 18, I will subtract the number 18, and then we'll see the summation except the number itself, whether it's greater than 18 or not. Right, as I did in the prime factors case, I am again repeating it. So whenever I will be able to find out 1 is a factor, I will also come out with 18. When I will be able to find out 2 is one of the factors of 18, then I will be able to find out 9. And once I am able to find out 3 is a factor of 18, 18 by 3 karenge, and we'll get to 6. Now the point is, till which step I need to do the iteration? I will still do the iteration till the under root, greatest integer of under root of 18. That's a concept, so we will increase the efficiency of the program. But in this case, where it's not an abundant number, the number 49, I will face certain difficulty. What will be the difficulty? Difficulty will be that this is a prime number also. It's a perfect square, sorry. It's a perfect square. So once I will be able to identify that 1 is one of the factors of it, then I will get 49, the other factor also from the same approach. But 7, in case of 7, I will get another factor which is 7. So I need to take care of this thing, that once I understand that the number is not a perfect square, I should print it only once, and I should not take 7 into account. That's the one thing that I need to be careful in case of perfect square. Else this program is same as the prime factors, the list of prime factors program. Right, you will see that list, that program in the comment box also, description box also. So you can look from there. So I'm going to start the code for the abundant number now. So let's start with the code. Guys, this program is all about the abundant number. So I will write it over here. Abundant number. And I'm using the same logic as I did to find out the factors of it, though it's slightly different because I need to add only the proper divisors of the number. Correct. But I will try to reduce the number of iterations as much as possible to make it more efficient. So now I have initiated the counter in which the sum of the proper divisors will be there. Right. Now num1 is my input, so I will take the input from the user. Input from the user, enter the number. Right. I also need to take care of two things: perfect square and non-perfect square numbers. Is this okay? Next one is what? The floor function. I will run the loop till under root of it only, as I did in the factors problem and the list of the prime factors also. It's almost on the same line. Sorry. So is equal to maths.floor. Correct. Num1 So this will have this thing. Now what, I will run the loop from 1 to a plus 1, so that it covers the last number. There is no problem with the loop. Now we will check if num1 is divisible by my iteration I equal to 0. If that is the case, then I will then check another I. If I is equal to num1, that's the case of the perfect square, guys. Kindly notice this. This is the case that we are running is for the perfect square number, right? If I is the under root of it. So let's say if the inputted number is 49, just I'm writing it down. If the inputted number is 49, then this will check over here, right? So if I is equal to under root of num1, then in that case, I will add I to S, correct? Next what? Correct. I'm not sure what is happening over here. S plus I. Next, I will move to else condition. Else, now this is the case that I'm referring is about the number 49. So the number is the 49, and the under root of it will be taken care of. Now, if it's the number is not a perfect square, in that case, if the number is a perfect square, then only this will happen, right? That this will become equal to the under root of 49. Else it will never become. Let's say in case of 48, it will never become equal to, I will never be equal to under root of 48, right? Because that's an integral quantity and that will be non-integral thing. Now in the case when it's not a perfect square, then I will again add I. I'm not sure what is happening. Why it's taking cap. Okay. Now, and I will also add the reverse of it. As I told you, in case of 48, if 6 is divisible by 48, then 48 by 6 will also be divisible by, well, if 6 is one of the factors of the divisors of 48, then 48 by 6 equal to 8 is also going to be a factor or a divisor of number 48. So this is the case of when the I is not a perfect square of the inputted number num1. Correct. So now I will add both the numbers at the same point of time, because my loop will go in case of 48, guys. Look here. In case of 48, so I'm writing it down now as 48. So my loop will run till 48 under root, that will be 6 point something. So my loop will run till 7 only. So I need to fetch the 8 also, so that my number of iterations are also reduced, and I'm doing both the things at the same point of time. I'm capturing 6 in my summation as well as 8 in my summation without letting my loop go till 8. I hope it's okay. Num1. So this is what I'm doing with this, right? So this is the case now. So if you look at this, this will capture something like 6. I'm just taking an example, right? And this will capture 48 divided by 6, 8 over here. Correct. Now what? I'm done with it. That's it. So, but in case of 7, there's a possibility of 49 being also captured. So I'm subtracting sum with num1. So the last number is also captured. I'm using the same theorem. So I'm reducing it, same theory as in case of prime factors, a list of factors that I did. So now if S1 is greater than num1, what I will do, I will print taking P capital. Right. Print the the number is num1 is an abandoned number. I hope all of us know why it's a number. So else you can print the number is not an abandoned. Correct, guys. So this is the case in which we are doing it. The same theory is running, and the same theory can be used for the sum of factors of a number also, where we need not put else condition. We just need to add all the factors and the reverse of it, and my factors will be added. Yes, guys. So let's try to run this. So as I know, I should check for 12 first. It is a problem in line number 7. What's the problem in line number 7? Oh, I haven't used the import math library function. Oh, now it should run IBD. So just a minute. Sorry. I will run it once again. So now enter the number 12. So 12 is an abundant number. I know that. Alright. Now 18 is my another trial. Yes, 18 is also the one. Next number I will take it as 24, let's say. So 24 is also an abundant number. So let me try for some other number. Let's say 8. 8 is not an abundant number. I hope it's okay. If the sum of the proper factors of a number is more than the number itself, then we call it an abundant number. So proper factors or proper divisors include all the factors, all the divisors of a number except the number itself. Is this okay, guys?